All right, welcome back everyone for this last talk of the 6th edition of the Legacy of Socrates. And after Andrea introducing empathy as a technical skill, Amitai sharing a lot of personal stories to illustrate how that translates into working with existing teams, existing code, etc. Now it's Felienne who is gonna talk about how do you read complex code. So Andrea said that code is communication, communicating with other people more than to the computer, because the computer can just do with 1 and 0 just fine. So you communicate to others. Now, when you are working with an existing code base who people are gone, this communication may be broken or may be difficult to get. And Amitai said that his definition of legacy code was code that is that you are afraid to change. So there's a notion of subjectivity. So everything, all of this compounds, I think, in Felienne talks. A little bit about Felienne before we start. So she's a professor at the Leiden Institute of Advanced Computer Science. She heads a PERL research group. She also is the creator of the Hedi, she probably will say it better than me, but Hedi programming language, and one of the founders of the Joy of Coding conference. I know Felienne because she is doing code reading workshops, and I attended one, and it was really good. I learned a lot of things about how you approach code, how you use your brain, like how your brain is working basically to approach new things, and how do you apply that with code. I'm going to share the link in the chat, but she is also the author of The Programmer's Brain, which is also dealing with all of this topic. So I'm going to drop a link in the chat so you can have a further look. But without further ado, Felienne, you're up.
Thank you so much for that introduction. Hello, everyone. I hope for you it's been a nice day so far and that I can bring some energy as a final talk of the day. I'm going to talk about how to read code today. By the way, I'm also on Twitter. I'm not sure if people are still on Twitter, but if they are, I'm on Twitter as well. My handle is @Felienne there. So if you want to check it out or mention me, if you're looking at the talks, then please go ahead. In order for you to understand how I came to study researching code, reading code, we have to go back a little bit into my own personal history. We have to go back to the year 2013, when I started to teach children at a community center in Rotterdam, where I lived at the time. So my background is in programming. I actually have a PhD in software engineering. This is what I had just completed when I started to teach these kids programming. So I thought, well, of course, children, I can teach you. I thought, how hard can it be? They are just little children. Even though I didn't know anything about teaching. I had done a little bit of teaching when I was in grad school, but nothing much, and this was 2 students, so it was very different. So I thought, how hard can it be? These were 10, 11, 12-year-olds, so how difficult can their questions be, right? And then what happened is that subconsciously, I started to think back of how I learned programming when I was about 10. So this is me, this is tiny Felienne behind my dad's very big computer at the time. And how did I learn programming? So this is the end of the 90s, end of the 80s, early 90s. There weren't people teaching. I didn't go to a programming lesson because at that time there were hardly any adults that knew programming. So I mainly learned programming from books. I had this book, in fact, Basic Computer Games, that allegedly taught children to make games. But it wasn't so much teaching, because if you would open this book, to some people this might be familiar, and this is what was in the books. This just printed out basic code. So there's not something like, oh, this is how it works. There isn't any explanation. It's just, here's some source code. And maybe you hear this, but I'm not a native English speaker. And when I was 10, I didn't know any English. So I also had no clue, like, what is if? What is next? I didn't know. I just mindlessly copied everything, and then after a while, I sort of figured out how everything worked. So really notice the absence of a programming teacher here. I didn't go through lessons, so I really didn't have any idea of what a programming lesson should look like. By the time that I was actually getting programming education, I was 18 and I was in university, and by then I was like ruined, right? I already knew many things. So I didn't have an idea of what programming education even was. And that isn't just me. Many people will recognize this story, people that are my age and grew up in the same way, that learned programming alone by themselves or with a bunch of friends, but not in a class. And this leads to the fact that this type of people, including me at the time, usually replicates this experience with their own children or with children that they are teaching. Because they're now let them explore. The underlying sentiment here seems to be that the compiler is the teacher. If you make a mistake, you will know. The compiler will tell you there's a mistake. So you don't need a real teacher because the compiler is the teacher. This is very much what I also believed at the time. And this is a vibe that you still very much see visible if you buy Programming for Kids books today in 2013. But I think in 2021, this is still equally true. So I have a few examples for you from Coding for Kids books from today. The snippets will be in Dutch, but then there's an English translation underneath. So here's one that says, the best part of programming is finding mistakes. That's a special thing to say, right? I don't even know I agree with this. Like, I don't like finding mistakes. I love programming, but I don't love finding mistakes. I mean, half of the time, I am the person that put in the mistakes. So I don't love finding mistakes. Usually this is accompanied by some self-hate, like, what idiot wrote this code? Oh, that would be me 2 months ago. Or sometimes this would be me yesterday. So I don't love finding mistakes. It takes a special person to say that finding mistakes is the most fun of programming. Here's another one. You will fail often and it will be frustrating. Again, these are books marketed at relatively young kids, right? You'll fail often. It will be frustrating. That's a weird thing to say to a kid that's moderately interested in programming because they are buying this book or looking at this book. This is also not something, it says so much about their culture, right, that we put this in a book. This isn't something you would see in a book, soccer for kids, right? It wouldn't say soccer is hard and frustrating. It would probably say like, oh, if you try your best and you too can be Ronaldo or Rapinoe or something. The fact that we celebrate that our craft is hard is very much indicative of what the stories we tell each other. Here's one that's also very important for this specific talk. The idea that you shouldn't be you shouldn't be afraid to mess around and experiment. That is also core to the thing that we tell each other. Oh, you should always try out stuff. Learn new libraries and frameworks, and don't be afraid to learn new things. So that is the culture of programming that we tell children, but of course you will recognize this isn't the thing we tell children. This is also very, very visible in the culture that we build with each other as software developers, software professionals. So I tried that as well. I had kids explore and mess around, but it didn't really work very well. The kids were really struggling and they weren't learning as much as I thought they would learn, or I thought they should learn or would learn, because they were just struggling all the time. And as a reminder, I didn't really know anything about teaching, but at this point, I got really, really interested and motivated to understand why those kids weren't learning. Because as I said, I taught a little bit in university, but then you have students, right? You can always make excuses for yourself. Oh, the students aren't motivated, maybe they're not so smart or whatever. But these kids in community center, they voluntarily came to the community center on their free Saturday afternoon to learn programming. So they were very motivated. And I could clearly see that most of them were actually also very smart, that they could really understand many other things. So the fact that they were failing to learn programming, it was on me. I was failing them. So I really wanted to know how do I get better at learning stuff. Specifically, I really dove into how people learn language, how people learn natural language. Because learning to read is such a complex thing, right? It's so hard to learn to read. We should be able to take something from that, I thought at the time, to learning programming, learning coding. And I learned many things from actually a deep understanding of how people teach other things. So the first thing that I realized is we never teach reading code. like ever. Like whether you go to university or in high school or if you attend a boot camp, there isn't a course of reading code. Like in my university where I teach now, we have like programming 1, programming 2, programming 3, data structures, algorithms, databases, systems. But there's no course that is reading code. That's sort of special. And I asked around, and this really isn't a thing that is explicitly taught. And this also at that point wasn't the thing I was explicitly teaching. I was sort of doing the reverse. So imagine a little something that more or less happened in my course at the time. There's this kid and it said, hey teacher, I made this code last week, but I don't really know, like I don't remember what is what. So what does this do again? I don't remember. And I would be like, what do you think, child? Because, right, never be afraid to mess around and experiment. I was very reluctant to just tell this kid what the code was doing. And I was even very reluctant to tell this kid how to get to the answer, which, if, as you can see, is not even such an easy question, because this is Scratch. Maybe if you're not familiar with it, it's a block-based language where kids can click together code, and it's an event-based language. So it isn't even like there's this linear thing where you can take the kid and say, well, this happens, and this function is defined, and these variables are defined, because like everything happens at once. Like an event can happen, a keyboard event, just like it can be ran in parallel even. So I didn't like give any help. I didn't say this is what you do. I also didn't say this is what it does. I really said, you know, what do you think? And the kid would be like, I don't know, teacher. This is why I ask you. I am stuck. I come to you for help. And then you say, what do you think? So that clearly wasn't a great strategy. And again, if you compare that to natural language teaching, if you teach your kid or if you observe your teacher interacting with your kid, suppose your kid says, hey, mommy, what does that word say? Will you tell them, well, I don't know, child. What do you think it says, right? It doesn't make any sense. If your kid cannot read, they're not going to guess what a word means. It just doesn't make any sense. So you probably like help them, right? You make the problem smaller. You take one letter and you say, do you recognize that first letter? It is also the first letter of the alphabet. And then maybe the kid says, oh, it's an A. And if the kid says, no, I don't even recognize that letter, you'll just tell them what the letter is, right? It's not some sort of secret that they can look. Observe the difference with programming. We're very, very reluctant typically to give these types of answers. And this isn't just for natural language. It's basically everyone else and programming, right? Imagine your kid goes to guitar lessons. Do you think the teacher will say, hey, here's a guitar. Welcome to guitar class. So how do I play the guitar, teacher? I don't know. You can figure it out, right? A guitar teacher is supposed to give small exercises to your kid to help them learn. And the same is true for sports. Like a tennis teacher is supposed to tell your kid, like, this is how you grab the racket. Not here's a racket, just put your hands wherever. So deliberate teaching and deliberate practice of really small things is something basically everyone uses but programming, which is kind of weird. So that's the first thing I took away from my exploration into learning language is we never teach kids or students or adults that are already professionals how to read code. It's just not a thing we do. Secondly, in addition to like teaching, we also don't practice reading code. Research shows that 58% of your time as professional developers is spent reading code rather than writing code. So it's the biggest task that you have is reading code. Yet we have this culture that we tell each other that if you want to get better at programming, you have to do more programming, right? Oh, you want to get better at programming, you need to join an open source project and program on Saturday and evenings. Otherwise, you're not passionate. You have to do programming all the time, right? But it's never, oh, if you want to be better at programming, read more code. No, it's always production that we center as the artifact of advancement. Because never be afraid to mess around and experiment. This is the story we tell the kids, is the story we tell ourselves. You should always interact with code because that's how you learn. Events we have as well, right? Maybe you're aware of Advent of Code, which always in December has this very nice idea of there's a puzzle every day and everyone can solve it. This is something we do, we tell each other to get better, to practice more. But then it is the Advent of writing code. Yeah, that's what it actually says. It's not the advent of reading code. So that's the second thing I figured, that we don't practice reading code deliberately or even like spontaneously. It's just not a thing that as a culture we say, oh, that's very valuable to do. The third thing that I picked up is that we don't really like study reading code as research topic. So I am a computer scientist, so I'm supposed to study computery things, programming and stuff. But we never really think about what even happens in your brain if you read code. There's some people that do that though. There's this fantastic professor in Germany called Jan Siegmund. She puts programmers in MRI scanners and she looks at what their brain do. So that's like super cool, but that's really just the first understanding of what happens. The nice thing though is we don't need all of that work. We can just look at what happens in your brain when you read something, when you process information. And already just applying the theories that we know holds true generically for information processing, only applying those to programming already really help us in understanding what happens. So I'm just, in the rest of the talk, going to do some sort of deep dive into cognitive science, into what happens in your brain if you process stuff. And we will look at how they reflect on how we process programming. So what happens in your brain? If information comes into your brain through your eyes or your ears, then this information is stored in the short-term memory, which is a little bit like an I/O buffer, where information is stored coming from the input very briefly. Research on the short-term memory is very old, actually. Already in the 1950s, George Miller studied memory, and he figured out that short-term memory is very, very, very small. He said that your short-term memory can only hold between 5 and 9 elements. You might know this result because it's typically called the magic number 7 plus or minus 2, from 5 to 9 elements. As an illustration of how small your short-term memory actually is, we're going to do a little memory exercise. So I'll show you a sentence very briefly, and it's your goal to remember the sentence. And you please be serious about this, and we can pretend that this is an exam and that you're really going to get graded on how well you will remember this sentence. So I hope you play along and do your absolute best to remember this sentence. Here we go. We'll go very briefly. So don't blink because you might miss it. Here we go. But that was really hard, right? That's like, yes, this is impossible, Felienne. This cannot be done. Well, that's maybe true, because I only showed you part of the equation. Yes, we have to go a little bit deeper into cognition to really understand your brain's working enough. If information is stored in your short-term memory, it is then processed by your working memory. And your working memory you can see as something like the processor of your brain, your CPU that does the processing of information that comes in. When information is processed in the working memory, the long-term memory is also activated. And your long-term memory is then searched for relevant facts. So your long-term memory is a bit like an angel on your shoulder, giving you relevant things. So if you think about, and maybe you think about a cloud, if you see this, my interpretation of a brain, you see a cloud, you think, oh, cloud, rain, white, sky. That's just stuff that your long-term memory associates and has handily, readily available for the working memory to use in processing the information that it sees. With that knowledge, I'm going to show you another sentence. And now I hope that this sentence is a little bit easier for you to process, understanding the information you have just seen also. Here we go. Are you ready? I guess that was easier. It was still hard, but it was easier because you felt the angel, right? It was jumping on your shoulder, right? It was going like A, N, K, B, R. Oh, these are letters. Oh, I know this stuff. Then still it was too short. But at least your brain was activated, was thinking, and was making sense of the information that was shown in a way that surely didn't happen in the first sentence. In the first sentence, you were like, and the angel was like, I got nothing, man. I have nothing for you. So do one more sentence, just so you can see that it is possible. I'm not tricking you into doing impossible things. It is possible to remember a sentence seen just this briefly. Here we go. You see, your brain can do this. Your brain can remember information if it's shown just like not even a second. Because what you're doing now is you're remembering cat and loaves and cake. You're not remembering individual elements. You're just remembering these three concepts. Your little angel goes like, C-A-T, cat, oh, cat, immediately. So these things come from the long-term memory. It isn't like this word is so easy. It isn't inherently easier than the other word I showed you in the first sentence. But because your long-term memory already knows what cake is, it is immediately retrieved for you from your memory. So, bringing this back to what happens in your brain if you read code, we are going to examine 3 different ways in which code can be hard to read, related to those 3 different memory systems. So here's a program for you written in a programming language called ADM. And if I would ask you to read this code and to tell me what it does, then this is hard, right? This T, you're like, I don't know what this T is. So this is a long-term memory issue, right? You just lack the knowledge. So nothing else that is the issue here, you just don't know what the T is, and that's it. But code can be confusing in very different ways. So here's a bit of Python code. And Python programmers might see that this is a list comprehension. So what happens here is a list is created. You sort of see that by the rectangular brackets, right? And then this list is created by looping over another list called customers and adding c.first name to the list when the c.age is bigger than 50. So it's not really hard, but there are many things to remember, right? Customer name is c.first name for c in customer if c.age bigger than 50. So easily you get above this limit of 9 elements. So this doesn't really fit in your short-term memory really well. It might if you know list comprehensions. So if you know Python, if you know list comprehensions, for you this might be cat loves cake, because you know what the individual elements are. But if you're not a Python programmer, if you're not familiar with this language concept, then for you this overloads your short-term memory. It's just potentially too much information to process. Let's look at this code. This is yet another totally different type of thing, right? So of course you need a little bit of long-term memory here as well. You need to know what is let and what is for and next and print. But I guess most programmers sort of know what's going on in individual keywords. But then still this is hard, right? Because you have to sort of debug, step through the code manually. You have to go like, oh, I don't know what this is. Let's take a value for not n. Let's do, oh, okay, so if n is 7, okay, now n1 is 3, and then b string gets to string 1. It costs you lots of processing power. So this is a working memory issue where code is understandable in practice. In principle, you know what these things do, but to actually connect all the wires takes lots of mental energy. So I think that the reason why many people are saying, oh, reading code is so hard is because they lack theories, right? They don't know why it is hard. They're like, oh, this is hard. Whereas, yeah, if you have short-term memory issues, it's really different from long-term memory issues. The people are just like, reading code is hard. It would be easier for me if I just not use this library that already exists, but rewrite everything from scratch, which can be very not cost-effective and very annoying also for people that wrote your code if this happens within a company. So the good news, I think, is that you can get better at reading code. If you understand your own confusion, you have better tools to actually understand what to do next also. For example, it is very important to realize that these different forms of confusions have different solutions. If you lack knowledge, if you have a long-term memory issue, you should just practice syntax. And this is something sort of culturally against the brain, right? We always say, oh, syntax doesn't matter, or you can just Google keywords. Yes, you can just Google keywords. But it's just not going to be very effective, right? Again, going back to natural language, we could tell children, hey children, this is the alphabet. It's just 26 letters. You can look any of these letters up on the internet. You don't have to practice words. You can look up any word in the English language or the Hungarian or Dutch or French language. You can look up any word. So, you don't have to practice. See how little sense that makes? See how slow of a reader in natural language you would be if you were looking up every letter or every word. See how much of a difference it made in those three examples, whether you had your long-term memory angel ready. The same is true for programming. The more syntax elements you know, something like a list comprehension, if you've seen this a gazillion times, it's easier for you to process. And you can do this if you're interested to check this out with a technique called flashcards, where you put syntax on one side of the card and the definition on the other side, and you can simply practice by yourself. And you can, of course, doesn't have to be paper flashcards. There are many apps also that you can use. If you have a short-term memory issue, if your brain is getting really full, then you can restructure code. Nice thing about programming is that you can rewrite something to be closer to your own prior knowledge. So if you're not so familiar with list comprehensions, you can simply take this list comprehension and make it into a normal loop. So here, this Python code, if you're not a Python programmer, this is exactly equal. This is the same code. And maybe if you aren't a Python programmer, if you aren't so familiar with list comprehension, maybe the second form for you is easier to understand, because it looks more like something you might also have in Java or Rust or that, right? So it's closer, it can be closer to your own prior knowledge. More familiar form means less elements in your short-term memory. And I call this technique a cognitive refactoring, where you refactor code. It's like a refactoring, right? Because the external behavior doesn't change. But you do this not to improve the state of the code base in general. As some people might say that you're making the code worse, you're making the code longer, but you're just moving it closer to your own prior cognitive information. So you're making it easier for you. And of course, if you're done with understanding, you can put the code back in its original form or just throw away your own fork or whatever. Then finally, looking at this issue, here you have a working memory issue. It's just like lots of processing power. And you can support your working memory, right? Maybe if you're doing this, this is something you intuitively already do. You take a pen and you're like, okay, let's see what happens here. Let me draw some diagrams, draw some state tables. And one of the things, there are many things you can do. The book has a number of them. But one of the things you can do is you can make a state table where you write down, okay, in these two lines, these are the values, and then this happens, and then with each iteration, different things happen. So your working memory can be supported, and then it's easier to process this type of complex code. So as a conclusion, understanding your own misunderstanding and understanding your own brain and what happens if you read code makes you a better programmer, because you will be better able to actually act upon your confusion. I've, in many situations, before I knew all this, I've read code and I was like, never mind. Like, I will never be able to understand this. I give up. I will write my own code. I'll just not participate in this project because it's too hard. But if you know about the different memory systems, if you know why something is hard, you can have more deliberate practice and also more access to an easier solution. So if you want to know more, there's many things you can do. But the first thing you can do, and should do maybe, but yeah, who am I to say because I wrote this book, is to read my book. I wrote a book called The Programmer's Brain that's coming out with Manning after the summer as a print book, but you can already buy and read the full ebook straight away. What we covered in this talk today was more or less the first chapter of the book. So we set the scene of cognitive science, but the book goes way deeper into that. So we also talk about cognition and code smells, cognition and variable names, how to do onboarding more efficiently, how to do API design in such a way that it's better for other people's brains. So if you want to know more, then I can definitely encourage you to read my book. Please do. It was lots of work to write this book. It took me, well, I think a decade and a half that I was preparing all this knowledge. So I would be very honored if you would actually see what I was up to. What you could also do, and this is what Nicola was talking about in the beginning of my talk, is start a code reading club at work. So something that I've been pioneering together with Katja Moordhout is a code reading club where you get together every month or every other month. It's just a bit how you want to organize it. You take a piece of code, just something randomly from GitHub or from your own repo, doesn't matter what you pick. And together as a group, you sit down and you discuss this code. And I have a link at the end of my talk to free resources that you can use if you want to start your own code reading club. So you have a bunch of code that you can use. You have an agenda with exercises for a bunch of meetings. So if you want to check this out, if this is something you can do, we have a bunch of free resources for you that you can check out. So that's it. That's everything I wanted to share. I think we should have quite some time for Q&A, so that's lovely. But before we go to Q&A, there's a bunch of closing remarks that I want to make. So first, let me just summarize everything we talked about today, because I guess it was a long day for you and it's warm, but at least it's warm where I am. So let's go over everything I discussed so you can get the gist of the talk again. I talked about how to read code, because reading code isn't the thing we do. We tell each other that interacting with code and trying out stuff is the path to enlightenment. But actually, we know from other fields that the way we process information very much depends on our long-term knowledge, on the things we have already stored. Different memory systems interact with code in a different way, and they also have different solutions. So if you want to strengthen your long-term memory, practicing syntax is best. If you want to lower the load on your short-term memory, refactoring code so that it's easier for you is best. And if you want to support your working memory, then drawing tables, making images, graphs, charts are all ways that you can support your working memory so it doesn't get overloaded. If you want to know more about my work, as I said, I'm on Twitter as Felienne, and you can go to my website as well, felienne.com, very easy, as long as you know how to spell my name. And if you go to felienne.com/book, I believe this is also posted in the chat, you can buy the book straight away. And if you buy the ebook, you can start reading today. If you want to know more about starting a code reading club, you can go to felienne.com/club, where we have free resources to start your own programming club. Maybe you're wondering in this talk, right, Felienne, what happened to the children? Because you started with, oh, those kids inspired me to learn stuff about cognitive science, and then we only talked about professionals. But actually, out of this exploration into cognitive science, two things came out. So the first thing is the book, but the other thing is a programming language for kids. So based on everything I know now about how people learn stuff, I also thought, maybe programming languages today aren't great for teaching kids. So I made a programming language called the HEDI programming language, that rather than teaching everything at once, thereby overloading your memory, slowly, gradually, we call this a gradual programming language, gradually teaches programming level by level. So it's called HEDI. It's an open source language. You can go to felienne.com/HEDI if you want to check it out. And it's now online in many different natural languages. So it's available in Dutch, of course, but also English, Hungarian, French, Spanish, Italian, Mandarin, and Swahili. So wherever you are, it's very likely that your kids and you yourself can program HEDI in your own mother tongue. Then finally, if you like listening to me and you're like, I would listen to that lady for hours and hours and hours while I commute or do the dishes, that is possible, because I'm one of the hosts of the IEEE podcast, Software Engineering Radio, an interview format podcast where every week we interview guests from the software engineering world about anything software engineering. So we have technical topics like databases, frameworks, programming languages, but also more the softer side of things, like how to do a job interview as a programmer or how to get better at writing documentation. So if you're interested in learning more about software engineering for free, you can definitely check out my podcast, Software Engineering Radio. And with that, I think we're good to go for questions. I'll stop my share so you can properly see me and I can see you as well.
Yeah, that's awesome. Thank you very much. And wow, that was great. And you have a lot of energy also, so that's very communicative. Yeah, we're waiting for questions, but I do have one actually, because so I'm wondering, all of this made me think the way we read code, the tools we use to read code. So today it's mostly, we have editors and they show you text inside a file and you read from top to bottom, from left to right. Personally, I do that. And I'm thinking we have syntax highlighting that is helping people. We can tell the difference when you're working in language with or without the syntax highlighting. But that's it. That's all the tools we have. So I wonder if you have like insights about better tools or a thing that could be improving that area.
Yeah, that's a great question. So there have been some other tools. So when I was a young grad student, so this is like more than 10 years ago. There was this tool called Code Bubbles that was supposed to like be a plugin into your IDE. I think it was a plugin for Visual Studio as well. Like this is before Visual Studio Code, where rather than showing a file full of methods, every method would be a bubble, and you could see like the call step. This was a thing that existed, and I don't really know. Like your question made me think, I don't really know what happened to it, but I do know like it never became mainstream. Like no one is using this. Maybe it's not a plugin in Visual Studio Code. I don't know, but this seems to be an answer to your question, and it didn't really like catch on, and I don't know why. So there have been experiments in that space, and I also think like somehow an IDE can also help you with more things than syntax highlighting, right? Because another cognitive refactoring I describe in the book is inlining a method. If you're new to a code base and you have all these calls, so you start, let's say, at the main method, right? And then it's like, oh, this goes there. Oh, and then this takes lots of cognitive energy to browse this code base. So one of the cognitive refactorings I also described, yeah, it is inline all of it, right? Inline everything into one big, the mother of all methods. And then you can simply read top to bottom. This is a refactoring that many IDEs can do for you, and then also undo or just throw away your code. So that's definitely a way that an IDE helps, and also code navigation. Like you control-click a method and you go everywhere. So I think IDEs can do some things, but yeah, there are many other things that you can still not do in IDE. In the Code Reading Club exercise, we have exercises where we print out code on paper, and we actually manually circle methods as a means also to dive into the code. That is a lovely exercise that people really like to do. It would be fantastic if an IDE had support for that, right? It would make links in the code and they would move with the code. So there's much engineering work to be done there.
Yeah, drawing on top of the code. I did that, and I also printed out the code, and that was really helpful to do the connections visually, and to interact, not being passive, but really interact with the code.
Yeah, because that's another thing that very often if we read code, we don't have activity. So you sit down, you read the code, and like, I don't get it. Then what shall I do? I can read it again. We don't have like activities, and that's something we're really trying to address with the Code Reading Club, where indeed, if you just sit down and you just mark all variables, it's a very boring thing to do, but it will help you see something you didn't see before, and at least something you can do. You have this whole toolbox of, okay, I can try this.
Nice. Well, thank you very much. Okay, we have a question from Julio, which is, what is the name of the scientist that put programmers in an MRI machine? Can you write it down for us? So
yes,
if you write
absolutely.
it down to me,
I can write it in the chat. Her name is Janet Siegmund. She's a German professor. So I put it in the chat so it can be shared. And you can my book also covers her research, because I mean, how cool is she, right? But if you just Google for her name, you can find much of her papers open access as well.
Sure. Oh, that's okay. That's it. So if anyone has any question, we have a couple more minutes. Otherwise, I'm gonna ask questions myself because I do have more.
By all means.
Yeah. Okay. So I was wondering about the pragmatic question about the code reading clubs, the workshops you are doing. Do you have is it something you will continue doing, or because I know you also want to help people organize that themselves on their place. So
yes.
What's the plan?
Yeah, so definitely you can see that if you go to the website, we have a mailing list where you can register. And one of the things we've been doing now is open Code Reading Club, where every month people, like random people, can just join in on a code reading session, just to get a sense of what is this, which I love, and everyone's welcome to join. Definitely, it's all for free. Definitely register and participate if you're curious. But what we found, like I've consulted for some companies that have Kickstarter groups, is that it's so good if you do it with your own team, because it also creates this empathy where you read a bunch of lines of code together, and you pick up this. You're like, oh, I saw this. And then we do this round of, what everyone found, and everyone found something different. And of course, that makes sense from what I told you, right? Your different brain shows you different things. But that's really has been an eye-opener for people. Like, oh, like something like this comprehension in Python. Oh, it's so easy for me. I'm a Python programmer, and then a Java programmer. Like, And you just, once you know something, you immediately forget how hard it was to not know that thing, right? So something like miscomprehension that you see every day, it can sometimes be really hard to remain understanding to people that don't have the right knowledge. And also you see this in the coaching club, you see still also this vibe of don't tell people stuff, right? Of they have to figure it out by themselves. And that's also something you can get rid of. So people are very much welcome to join our workshops. I hope we will keep this monthly thing up because it's been really valuable for me as a facilitator to get better at facilitating. So everyone's super welcome. But it's even more valuable because if you create this shared understanding, also a shared vocabulary within your team, that you're like, oh, this code is so hard. Oh yeah, it's like the one code that we read in code reading club. It had the same construct or it was equally confusing. You get this whole vocabulary as a team. So we also put all these resources online for free to encourage people to start this within their own companies. And if they want me to help out, especially remote, it's very easy for me to sit in or to kickstart something, then definitely reach out. We have a contact info on the website as well. And I want to stress that this is not just me. We're doing this with 4 people together.
That's great. That's great. And yes, I've seen all of the resources. I actually plan to do the same when we can meet again in the Software Crafters Montreal meetup. I think we'll have some of. I just prefer that to be in real life. With people. Missed that, but soon.
Well, if you do, let me know.
Yeah, sure. And thank you for putting all of this available online. We have one fine, and I think that will be the last question. Okay, so when trying to understand an entirely new code base, do you find it helpful to separate into layers? There is more detail in the
like
question.
Architectural layer.
Yeah, so the explanation says, okay, so for example, the outer layer for the use cases, then another layer for the conceptual modules, then the actual classes, then implementation details. Like, do you do layers, or do you have any other kind of advice when approaching a completely new code base you're not familiar with?
Yeah, so the separation we make, so first to answer the layers question. If these layers already exist in the code base, then that can be really an exploration path. So I think I wouldn't restructure everything towards that, but if it's already there, it can be helpful. But something that we do, like we take 2 streams. We say, well, you have to know the domain and you have to know the programming constructs, the concepts in programming that are being used. So an exercise we have for that is, this is again a mindlessly numb exercise, but it's really helpful, is you take a Word document or pen and paper, you write down all the variable names. All the variable names, if you want to, if you have more time, you can also have it include all function names, all method names, all class names, all everything. You don't look at the code base anymore. Now, the code base is gone, you only look at your sheet of paper. This is your knowledge base. You're going to look at all the words. Do you know what all the words mean? And this you do in domain and in programming. So you look at all the domain concepts. Do I know the meaning of all these words? And if you don't, you're going to check with the project owner, the product owner, the team, right? To really get a definition, because if there are words that are confusing to you, if you don't really know what the domain is, you will not have a fun time understanding this code base. So that's the first thing you do. And then the other thing you do is you're going to look at the programming concepts, like lists and loops and heaps and whatever. Do you really understand all the concepts that are being used? Because if there's something like a tree search or whatever, if you don't know how that works, then that's also not going to give you a fun time in that code base. So this is a very concrete exercise that you can do that is away from the code, which I like because code can be super scary. If you don't know a code base, it can really be like, oh my God, I will never be ready for this, right? So it's nice to first be away from the code base. You can train, you can ask around, you can ask all your teammates, like, oh, I didn't really understand that. That is a very good first step that I really would recommend. And I know people might be now like, oh, that sounds like a lot of work. Yeah, that's a lot of work. I don't have happy news that I can just say, oh, here's this magic trick and you can learn any code base in 5 minutes. This is a scam, people. So of course it will take much energy, but understanding the domain concepts while also browsing the code base and interacting with the IDE is going to be even horrible. So splitting this up in smaller tasks is probably going to be more fun. So that's definitely the approach I always advise people.
Thank you. I think that answers the question very, very well. All right, so I see no other questions, so we're gonna wrap it up. Thank you very much. That was a very refreshing last talk also. So I encourage everyone to, if you are interested to dig into this further, Felienne has shared a lot of links, and the video will be available very soon on YouTube, so you can revisit that talk. You can also share it with others, and we will also get the slides and make it available for everyone, so you can access all of the links. All right. Anything you want to say? Final word, Felienne?
No, I'm good. Thank you so much for having me. I hope we can have normal conferences soon.
Soon.
Even more. Always there.
All right. Well, looking forward. Okay. Adi,